Continuing with our three-dimensional images or three-dimensional figures, we're going to start talking about that surface area and how to calculate it. There are formulas included on the state reference sheet, of course, but generally being able to understand it and the surface area and how to add that information up. But we talk about the surface area of prisms or cylinders. The surface area is the outside area. Just think if you were to paint an object, the surface area is where the paint covers the outside of it. So the difference between the surface area and then we have a special thing called the lateral area. The surface area is going to include the bases, where the lateral area is the sides. So if you look at this image right here, you have this blue is intended to be the lateral area or the sides of the item. And then your bases are going to be the bottom in this image, the bottom triangle and the top triangle. Those are my bases. So your lateral area is the stuff that would be included on the sides if an item was sitting on its base. And then looking here at the cylinder, the same thing. The lateral area is the blue shaded area, and then the bases would be the top and the bottom. Okay, so just being able to distinguish between the lateral area and the total surface area makes a difference. So the formula they come up with here is the lateral area of a right prism is going to be the perimeter of the base. Okay, so if we were to take the entire perimeter, add it up, and then multiply it times the height, that would become the lateral area. Another way to think about that too is I could calculate just the area of this side, length times width, the area of this side, length times width, and then the area of the third side, length times width, and just add those two areas up, those three areas up. That would also be the lateral area. It just depends what is easiest for you or the problem, but there are formulas. Looking here at the cylinder has a base, which is a circle. So the perimeter, in essence, is going to be the circumference of that circle. That's why, you remember, the circumference is equal to 2 pi r, or just pi times diameter. Well, here, if you look in the formula, 2 pi r, there's my circumference, which would be the perimeter, times the height. So the same concept, we're finding the perimeter of the base, then multiplying it times the height. Okay, so there you go. Looking at the surface area of the right prism, well, of course, the surface area, now we have the lateral height, plus we need to add in the two bases. So that's not included. So there you go. There's the slight change is the total surface area for a cylinder, for example. We had to include the top and the bottom, which is in the formula. The surface area is, this was my lateral area, and then 2 times the area of the top and the area of the bottom. So just understanding how do we derive that. Okay, and then the right the right prism, of course, is the lateral area and then 2 times the area of the base, whatever that base may be. The base may be a rectangle, it may be a triangle, it may be a pentagon, whatever that may be. So just being able to distinguish between lateral area, surface area, what are the components of the formula to where you're able to fill it in. Now, as we talk about lateral area and surface area of a prism, it wants us to, find the lateral area and surface area of the prism, round to the nearest tenth if necessary. Okay, looking here, it says the lateral area. Remember, they came up with the perimeter times height. So looking at this object, they're saying that this octagon, the octagon is going to be the base. And of course, we have 2 octagons, so if we were to stand that up on its side, it would, the octagon shape, whatever that may be, and then there's my sides. Okay, so it's saying that we stood that thing up. So if it's an octagon, we know that all of these sides would technically be 6s. So that's why they said, hey, the perimeter is going to be 6 times 8, because there's 8 of those little sides is 48. And then this is going to be my height, which is 11. And they just multiplied that out, and they came up with 528. We're talking about area, so again, that would be inches squared, square inches. And that's how they came up with that. Now, if we start to go to surface area, in order to come up with the surface area, you can break this thing up. Let me erase this so we can look at it. I can technically, if I wanted to find now the surface area of the base, the surface area of the base is a octagon. So I need to think, okay, well, I have a center, and what we're skipping ahead. This is section 11, so there's some things that we won't have covered yet, but we're going to go back and cover them later on. But I'm going to provide that. Just looking at this, think of this as, I could say that there are 8 triangles here. Okay, I have 8 triangles. And if I can calculate the area of one triangle, I can just multiply it times 8, and that gives me the area of one base. So as we think about the area of a triangle, you have to come up with the height times the base, the base, and then 1/2, right? So the area of a triangle is equal to 1/2 base times height. So we can do that. We can multiply it by 8, and there's going to be things that we're able to work with. In this section, they talk about the apothem, and that is this value right here, and we will learn more about that later on. But the apothem is simply your height of your triangle. And since we haven't covered that yet, I will provide that for any questions that are necessary for this unit, because we'll talk more about that later on, using trigonometry to find the apothem and those kind of things. But just understanding, how do we deconstruct that image to be able to calculate the area? So we all have that capability. If you break it down into, those geometric shapes that we understand, that we've learned about, we can calculate that information. So that's what happens when they did the surface area, when they calculated the area of the base. Ultimately, again, we'll worry about that, but the way to do it is 1/2 times the perimeter times the apothem, which is nothing more than the height, and I will provide that information. And then they added it all together. They said, okay, well, if one base is 173.8, the lateral is 528, then they said, okay, well, my lateral area and then 2 times my bases gives me a total of 875.6, and 875.6 square inches, or inches squared, when we're calculating that. So looking at that, just being able to break things apart into useful components, breaking it down into small manageable pieces. As we talk about cylinders again might be a little bit easier because we're not creating the apothem and those kind of things, but I have a circle. That is my base. So calculating the area of a circle would be easy, or the circumference, which would give me my perimeter. So again, 2 the perimeter times the height. If in this situation, if the diameter is 10, that means my radius is 5. So that's how they came up with some of these values, being able to just break that apart. So the circumference is 2 times pi times my radius times the height, and that is how we came up with the lateral area. Okay, the lateral area. If we wanted to calculate the entire surface area, we have the lateral area plus 2 times the base. And the base, the area for a circle, right? The area of a circle is equal to pi r squared. And that's what they did. They just said, hey, we got 2 bases, so multiply 2 times the area of the base. Added those 2 things together and came up with 439.8. And again, square inches, or inches squared, because area is a length times a width in essence. Okay, so differentiating between lateral and surface area, being able to calculate both, understanding how you derive the formulas or what is in the formula will make it easier for you. Here again, looking at these formulas, they are provided to us on our sheet, possibly a little bit different, but the concept is going to be the same. We don't break up, the state of Tennessee does not break up or distinguish the difference between lateral area and surface area on the formula sheet. So you do have to understand what the difference is and how to make that determination. So here, just looking at this, being able to, the lateral area would be calculating the base, or not the base, but the perimeter of the base, and then multiplying times the height times 1/2. Or as you can see, the lateral area of a pyramid is actually 4 different triangles. A cone, the lateral area, the surface area of a cone is going to be the lateral area plus the area of the base. So we have the surface area, so if we understand that if we remove the base, then the lateral area is just pi RL. And think about a sugar cone, ice cream cone, that's what we're calculating. We're not calculating the open hole, we are calculating just the cone portion of it. And then again, when we move from lateral area to surface area, we start including the area of the base. Okay, and that is included in the formulas. And big B, of course, is identified on your reference sheet as the area of the base. So there you go, distinguishing those features. Let's see here, being able to look at this and understand what is the difference between the lateral area or the lateral height versus the regular height of an object. So since in this example, the lateral area and surface area of a regular pyramid, how do we calculate that? The formula is 1/2 the perimeter times the lateral area. So 1/2 times the perimeter. If this is a triangular pyramid, this is 6, this is 6, and this is 6, or they just said 6 times 3 is 18. Then the lateral height, again, on the side is the lateral height, is 8, and then they said, hey, the lateral area of the pyramid is 72 square feet. Adding the surface area, now you have got to come up with the area of the base. Okay, the area of the base, and if I did that, the area of the base, equilateral triangle, this would be 6, 6, 6. My triangle, the height there, I need to calculate that. And if I break that down a little bit more and I turn around and say, okay, well, that triangle, this is 6, this is 3, how can I figure out what the height is? I can use Pythagorean theorem, and that's what they did. They said, okay, a squared plus b squared equals c squared. I am trying to find this missing side, which is a squared, and this would be b, this would be c, and they came up with the height is the square root of 27. So that's what they ended up coming up with. So when they did that, there was a formula for the area of the base. And so now that they have the height. So you have the area of the base is going to be 1/2, I don't know why I'm doing it so small, 1/2 times the base times the height, and then they said the area of the base of my triangular pyramid is going to be 15.6. To calculate the entire surface area, we just add those two numbers together and came up with 87.6. So there you go. Being able just to break it down into those manageable little pieces. And I guess make sure I clarify that this triangle right here is the same as this triangle right here. We sort of broke it up. Lateral area and surface area of that right cone. Again, here is this is my lateral height. This is my radius, looking at my image, and it says to find the lateral area and surface area of the cone, round to the nearest tenth. Those are the only two items that you need to find the surface area or lateral area of a cone. So the lateral area is pi times r times L. They've given you your radius and your lateral height. You just multiply it out. So my lateral area is 5.5. The surface area, you add in, we're going to take the lateral area plus the area of the base, which is a circle. You have the radius for that, so you just, there we go. We just combine those two items and it comes out to be 7.5. So the surface area of the cone is approximately 7.5 millimeters squared. Okay, so just being able to, again, and I have the base here, looking at the base, this is 0.8 millimeters, which is my radius. So calculating your area. So with that, starting to look at real world examples, same thing applies. We start looking at algebra. Shouldn't be that big of a deal, but looking at this, hopefully you can see that this, it may be hard to see on our copy, but this is intended to be a triangular pyramid. So they're saying that the height of one side is equal to 4x minus 4. The base of the triangle, the base of that, would be equal to 2x. There you go. So I can use that information to calculate the information I need. The surface area or the lateral area, just being able to distinguish that in my, and I don't know why somebody would make a triangular watermelon, but hey, the things we do to get a word problem in math sometimes. So there we go. Looking at that, here's my triangular pyramid, the height, the lateral height. Let me change this. This is the lateral height, okay? Sort of important. And then if one side is 2x, then my perimeter would simply be 2x plus 2x plus 2x, or 3 times 2x, which is 6x. So just thinking of those kind of things. Let's see here. As we filled in that information, turns around and says, we want, let's see here, specialty watermelons are carefully cultivated in containers so that the fruits form geometric shapes. Kurt wants to build molds to grow watermelons shaped like triangular pyramids. Find the surface area of the mold in terms of x. Okay, so we have the information we needed to come up with surface area for the lateral area, but we need to calculate the area of the triangular base of the pyramid, which is 1/2 base times height. And they were able to calculate the height of the triangle base as x square root of 3. And then the length is of the base is 2x. And then substituting those values into my formula, they were able to substitute these values into the formula for the area of the triangle to find the area of the base of the pyramid. Okay, so the base is equal to 1/2 times the base times the height, and then substituting in your information, we came up with an approximate surface area. This is the formula for the surface area. And then x would be 6. If x is 6, approximate the surface area of the watermelon. So there you go. We just plug in the value of x, and he's saying, hey, substituting that in, working the problem out, the surface area then would be 422.4 inches squared. So there we go as we continue on. Surface area of a sphere, very easy. Okay, we only have to replace one item in the surface area of the sphere, and we need to have radius. Okay, once we calculate the radius, then the rest of the information is done with the calculator. So here, 7.1 is my radius. So I just plug that into the equation. 4 times pi times 7.1 squared is 633.5 millimeters squared. And then I will just look at this one. I'm not going to work the whole thing out, but if my diameter here is 22, Remember, your radius is going to be 1/2 the diameter, or in this case, your radius is 11. So you simply have the surface area is equal to 4 times pi times your radius squared, and that gives you your surface area. So I'm not going to work that one out, but if you can do the problem, this is what I need to see on a piece of paper saying I knew how to fill the formula in properly, and then give me the answer. Same thing here. Just because we have included an algebraic expression doesn't change anything per se. If my circumference is 3 pi x squared, well, I also know that the formula for circumference is 2 pi r. So we take the circumference of the item equal to the circumference of the formula, and that allows us to find some of the information out. So if I start combining like terms, and I divide pi from both sides, pi simplifies to the value of 1. I get 3x squared is equal to 2r. My radius then, I need to isolate my radius. I divide by 2, and then my radius is actually equal to 3/2 x squared. And that's how they came up with my radius. And then once you know the radius, you just plug it into the equation and follow through with the formula. So if I have, in this case, 4 times pi times 3/2 x squared, remember this squared goes to everything, so I have 4 times pi times 9/4 times x to the 4th. And then I can keep working that out, which I think will simplify down to 9 pi x to the 4th. So there you go. Just because it was an algebraic expression doesn't mean that we don't do it differently, or do it differently. We do the same things. It just maybe looks a little bit different when we're done. Composite solids, same thing. You have to think about what you're painting, what you're not painting when it comes to surface area. You don't have formulas for every composite object out there, but we can break it down into things that we understand. For example, what they're trying to say here in this image is that we have a half cylinder up top of our mailbox, and then we have a rectangular prism in the bottom. So that's what they're doing there, is they're saying, hey, look how we can break this into pieces that are useful to us. Manufacturer wants to know the approximate area of the metal used to create that can. Okay, so we have the half cylinder, breaking it down into components, and being able to calculate the surface area. And there it is. For example, this is a 12, this is a 12, this is 7, 7, 7, 7, 12. So I know this is 12 times 7, this is 12 times 7, this is 12 times 7. So I have 3 of those. This is 7 times 7, 7 times 7. I have 2 of those. So there's my 3 sides, my 2 ends, and then they turned around and find the area of a circle. So a half circle plus a half circle equals a whole circle. And then, again, length times width to come up with that. So there's plenty of information in here. We have plenty of the requisite skills to break things apart and put them into objects, and that's identifying those real-world objects and using geometric terms to solve and simplify things in life. And with that, we'll move on. Again, most of the challenging part is just being able to distinguish what values they're giving us, and understanding the lateral height, understanding the lateral surface, understanding the difference between radius, diameter, understanding the difference between lateral height and height. So with practice, it all becomes a little bit second nature.